We continue with matrices, where we first introduced what a matrix is and how to refer to its elements, and we will look at a couple of different types of matrices. We already said that we had a square matrix A, and an example was 2 by 2 square matrix. A square matrix has the same number of rows as it has a number of columns. So a square matrix, matrix A is square if the number of rows equal the number of columns, and this then is an m times n matrix. So if the number of rows and columns are equal, it is called square. We can have a diagonal matrix, and a diagonal matrix only has elements on the main diagonal. So for example, the matrix 1 0 0 0 minus 4 0 0 0 5 is a diagonal matrix. A diagonal matrix is always square, and a diagonal matrix has elements that may be non-zero here, but definitely all the other elements must be equal to 0. So this is a diagonal matrix, and a special kind of diagonal matrix is the identity matrix. And the identity matrix, just like any square matrix, comes in different sizes. You can have this one. It is usually indicated with a capital letter I with a number describing the size. So this is a 2 by 2 matrix. That's where the 2 comes from. I3 is 1 0 0 0 1 0. This is the 3 by 3 identity matrix, and it is a diagonal matrix with only ones on the main diagonal. And that's pretty much it. It has a lot of uses as like a unit vector has, or 1 in when we look at numbers. So these are different types of matrices, and well, next we'll go into some operations we can do on matrices, and the first one is the transpose of A. Of a matrix A, which is m times n. So the transpose of a matrix m, which has size m times n, it is a matrix AT, which has dimensions n times m. So it is important to note that this m here, the number of rows, becomes the number of columns, and the number of columns becomes the number of rows. And how do we get a transpose? Is that the ith row of A becomes the ith column of a transpose. So if we take a matrix A, let's say 1 3 4 1 2 minus 1 0 2, well, 0 through 3 1. If this is A, then the transposed matrix we get by taking the first column and turning that into the first, the first row, and turning that into the first column. So that is 1 3 4. We take the second row, and that becomes the second column, and we take the third row, and that becomes the third column. And this is how we determine the transpose. And transpose, again, is used in all kinds of operations, but also in one important one where we calculate the inverse of a matrix. We will need this for the formal calculation. So we have different types of matrices, a square matrix, a diagonal matrix, and an identity matrix. And from a given matrix, and it doesn't matter which size it is, because if A were equal to 1, 2, 3, 4, minus 1, 0, 2, 5, this is a 2 by 4 matrix. We can calculate the transpose of this matrix, which will become a 4 by 2 matrix. The first row becomes the first column, and the second row becomes the second column. So a matrix does not have to be square to have a transpose. So every matrix has a transpose. So we'll continue in the next video where we'll be looking at addition, scalar multiplication, and the multiplication of matrices.